Morning. Yeah, this is the third lecture uh, on the topic of law of gravitation. In the first class, Newton's law of universal gravitation was discussed. In the second class, gravitational field was discussed, and this is the third class on the same chapter. Today's topic is gravitational potential. Gravitational potential. Already you are habituated in using the term potential energy at a point. If you take one object of mass m at a height h from the surface of the earth, then you write that potential energy at that height is equal to mgh, where m is the mass of the object, g is acceleration due to gravity, and h is the height. Height is measured from the surface of the earth. Okay. Question is, what is the potential energy on the surface of the earth? Most of the students answer to this question as zero. Potential energy at the surface of the earth is zero. Actually, that is a wrong answer. That is wrong answer. And when we say that potential energy at that point at a height h is mgh, that is also wrong. That is actually gain in potential energy. When you are lifting one object of mass m from the surface of the earth up to a height h, means you are raising that mass to a height h, then gain in potential energy is mgh. That is not the potential energy at that point, at that location. That is gain. And when the object is placed on the surface of the earth, still it has some potential energy. Because suppose this is the earth's surface and here this is the object. At this location the object is there. If you dig a well just below that object, if you dig a well, okay, just below that object, then what you will observe? You will observe that that object of mass m falls into the well. It will reach to the bottom of the well. How it is possible? Because on the surface of the earth, the object had some potential energy. And by spending that potential energy, it goes up to the bottom of the well. It went up to the bottom of the well by using that potential energy. If the object had no potential energy, then it was not possible. Clear? Potential energy will be zero only at the center of the earth. Only at the center of the earth potential energy will be zero. Otherwise, in any other place on earth, there will be some potential energy. Now, today's topic is gravitational potential. Suppose there is, just talk about our earth. This has the mass capital M. Okay, capital M. This has the mass capital M. Capital G is again that universal gravitational constant. And suppose so it has gravitational field around earth. Gravitational field is there. Whenever you place one object in the gravitational field, the earth will attract that object. Okay. The size or mass of the object is very, very small as compared to earth. Actually, both are attracting each other. We are saying that here, earth is attracting that small mass m. Now, if you want to increase the distance of that mass from earth, what you have to do? You have to do some work. You have to do some work on that mass. You have to apply some force against gravity of the earth. And whenever you are applying some force, and by applying that force must be opposite to the direction of attraction. Attraction by what? Attraction by earth. Okay. So you need to apply some force minimum value of which should be attraction by earth. So you need to apply that force, and by the application of that force, that small mass of m, small m, okay, mass of that object is small m, that mass will move to some distance. If F is the applied force and x is the displacement by which you are moving that object, then work done will be F into x, that is the work done, and that work done will be stored in that small object. Okay, that work done will be stored in that small object. As soon as you are removing the application of force, then using that stored energy is called potential energy of that object, of that small object. By using that potential energy which is stored in that small object, it will again come back near to the earth. Okay. So whenever you are moving that object from one point to another, suppose from point A to point B, then some energy is being stored in that small object. And we say that potential, we use one term, potential difference. Potential difference, which is equal to work done. So initial point was A, final point was B. Therefore, potential difference is written as VB minus VA. A and B are suffixes, okay? V suffix B minus V suffix A, that is equal to work done. So VB minus VA is written as WAB. WAB means work done is from point A to point B. That's why first you write A, the suffix A, then write the suffix B. So VB minus VA is equal to WAB. So this is the potential difference between these 2 points for mass m. So what is the potential difference per unit mass? It is equal to nothing but that WAB divided by m. WAB divided by m. That is the potential difference. So this way potential difference is written per unit mass. So both at point A and point B, the object has some energy, which is called potential energy. Okay. Now question is how we will write the potential energy at a point. This was the difference, VA minus VB. This was the potential difference. Okay. Gravitational potential difference. This was this. Now question is, what is the potential energy at point A? So to assign a value of potential energy at a point, one concept is used, that is, if you bring a mass of m from infinity to that point A, we are interested at point A. What is the potential energy at point A? Of course, that point is a gravitational field. If there is no gravitational field, then there is no question of potential energy or gravitational potential. If there is no gravitational field, we are talking about Earth. Therefore, due to the presence of Earth, around the Earth, gravitational field is there. What is the extent of this gravitational field? Mathematically, it is infinity. According to Newton's law of universal gravitation. Because the formula is force of attraction is equal to gmm by r square. Okay. Very simple formula. Gmm by r square. And you know that according to this formula, just by using this formula, we can say that gravitational field will be zero only when r will be infinity. Only when r will be infinity, gravitational field will be zero. Means there will be no gravitational field at a distance infinity. So this is done this way, that if you take a mass of m and if you bring that mass of m from infinity to the point A. Point A is within the gravitational field of Earth. Okay. If you take a mass of m from infinity to point A, there will be some work done. There will be some work done. That work done is equal to the gravitational potential of point A from infinity to A. When you are taking that object of mass m from infinity to A, who is doing the work? That is the question. Who is doing the work? Earth is attracting that small object. So the movement is towards the Earth when you are taking that object of mass m toward point A. In that case, force of attraction is acting. Force of attraction by Earth is acting on that small object. That means that small object is doing work. And whenever you are taking an object from a point A to point B, where point A is nearer to Earth and point B is away from the Earth. Means distance of point A is less and distance of point B is more from Earth. In that case, what happens? Force of attraction is acting on that mass, and that force of attraction is doing that work. So the object itself is doing that work. And when you are doing the just reverse process, that is from A to B, that means you need to apply some force against gravity of Earth on that object to bring that object from point A to point B. That means you are doing some work on that object, on that small object. You are doing some work. So therefore, some potential energy will be, that work done will be stored as a form of potential energy in that small object. And whenever you are doing the reverse process, then potential energy will be spent in doing that work. That means whenever you are taking one object from infinity to point A, some energy is being spent by that object. Okay, and that energy is equal to gravitational potential of that point. Of that point means of the point A. Now, how you will calculate this? You know that according to the formula, force is equal to gmm by r square. Means whenever that distance from the center of the earth, that r is measured from center of the earth. Okay. So whenever r changes, force changes. You are taking that object from infinity to up to point A. So continuously force is changing. So how will you calculate the work done? Force is continuously changing. If force is constant, then force multiplied by the distance is equal to work done. But here force is continuously changing. So to calculate this thing, you need to take the help of calculus. Take any point at a distance x from the center of the earth, at a distance x, you take any point and then make a small displacement dx and calculate work done for that small displacement dx. Dx means differential displacement. So at a distance x, what is the force of attraction? It is equal to gmm by x square. Distance is x, so force will be gmm by x square. Displacement is how much? It is dx. So what is the work done for that small displacement? It is gmm by x square multiplied by dx. Then what is the total work done? It is integration of that expression gmm by x square into dx. Then if you take that particle, if you bring that particle from infinity to point A, okay, say point A is at a distance of r. Point A is at a distance of r from the center of earth, small r, okay. Then the total work done will be integration of gmm by x square into dx, and integration limit, lower limit will be infinity and the upper limit will be small r. Lower limit will be infinity and the upper limit will be small r. Integrate this, you will get the answer. That will be the potential energy, gravitational potential for the mass m. So what is gravitational potential per unit mass? You divide that result by small m, mass of the object. So now integrate gmm by x square into dx, gmm, all these three things are constant. Take these three things outside the integral sign. So within the integral sign, what is there? X to the power minus 2 into dx. Result is what? Minus 1 by x. Now put the limits. What will be then? You take the minus sign outside the integral sign. 1 by x, right, 1 by x, then 1 by r minus 1 by infinity. So ultimately 1 by r. So result is minus gmm by r. Okay, result is minus gmm by r, and divide this work done by the mass of the small object, means small m. So result will be minus gm by r. So therefore gravitational potential at the location A is minus gm by r. R is not radius of earth. Small r is here, not radius of earth. It is the distance of point A from the center of earth. Okay, it is the distance of the point A from the center of earth. So at point A, gravitational potential is minus gm by r. Again, if you use this formula, minus gm by r, and if you want to calculate gravitational potential at a location infinity from earth, then the gravitational potential will be 0. Minus gm by infinity is 0. G is not 0, m is not 0. So some non-zero quantity divided by infinity is equal to 0. Okay. Once again, I want to say the same thing, that if you have any queries, please write in the comment box. I am talking about YouTube channel. The same video will be posted to YouTube channel as well as my Facebook account. And later I will try to post all these videos in my Facebook page. I have already Facebook page, but I am not going to post these videos to my Facebook page right now. Later I will do the same thing, okay? I will post all my videos to my Facebook page. And now at present I am posting all these videos to my Facebook account and as well as YouTube channel. Okay, thank you.